folks, this is Praveen, and in this video, we'll see SQL database and the concepts. So the NoSQL is the short form of not only SQL. There's a misunderstanding from its name. It does not support SQL, but there are some databases which has their own query languages written on top of the SQL. So it does support the SQL in some form. So NoSQL database are non-relational database, which means there's no relationship between the data stored in the tables. Uh, Most of the NoSQL database stores data in non-tabular format. The basis of non-SQL database are the key value stores. The NoSQL database are schema list. So unlike the relational database, we don't need to define the table structure in advance. Each row can contain different data from the other. Let's talk about the advantages of the NoSQL databases. One is definitely the scalability. So NoSQL databases are highly scalable as there's no relationship between the data. It's really scaled well. Second one is the flexibility. So they are flexible because there's no schema defined, and each row can contain the different record from the other. So in that way, it is really flexible when it comes to store the data. They are really fast when it comes to the work with very huge data. The performance of NoSQL database are really seems to be very fast. So these are few advantages of it. So let's talk about the relational versus NoSQL databases. So the relational databases are reliable. They are being used like from very long time. They are like well robust tested in like different scenarios. So they are really reliable. They are consistent. So data like when it comes to the consistency, the relational database are like still on top. Uh, they have excellent integrity. So the data which is stored, like it's always correct. So the integrity part is also very like high priority for the relational databases. They really support the complex query. So when it comes to the complex query, uh, there's no match for the relational databases. But like it has the fixed schema, so we have to define the schema in advance with the relational databases. It supports the like ACID transactions, which is like atomicity, consistency, isolation, and the durability. And they are like designed for the vertical scalable. So when I say vertically scalable, that means we can scale that particular machine where that DB is installed. There are scenarios where we can do the horizontal scaling of the non-relational database, but in that case, we might compromise with the consistency and the ACID transaction. And that doesn't come out of the box with the databases. Now let's talk about the non-SQL databases. They are highly scalable, they are flexible, they are fast, and they are well suited for the hierarchical data or the unstructured data. So when we have certain kind of hierarchy or data is unstructured, the NoSQL database goes well with that. And they actually support the base transaction. This is basically available, soft state, and eventually consistent. Data will eventually gonna consistent across the nodes. So that is basically the comparison between the relational versus NoSQL databases. Now let's talk about, let's see, like before jumping into the NoSQL, let's understand how the relational database stores the data. So if we'll see, like here we are having one user table where like we have defined certain column ID, first name, last name, date of birth, city, state, country, and pin, and each row would be having the same data, like whatever the columns we have defined. If we are not giving any data, like the city or state for certain column is not defined, so that will store the null in place of that value. And we have the order table. Let's say there is an order for the user ID 111, which is defined in the user table, and we'll be having some value for that. So we can define the relationship between the tables. So user and the order table is having one-to-many relationship, and the user ID is kind of a foreign key here. So this is what the structure we can define in the relational databases. Now let's talk about the NoSQL databases. So if we can see the same table I have converted, like tried to demonstrate as in the NoSQL database. So here, if we'll notice, there's no column, the column definition defined. So each cell will contain the key value. So if we'll see, the key is ID and the value is 111. Similarly, the first name is a key and the value is ABC. So like that, we can store the data. And here the pin is 001. So the one row can be completely different from the other row because it is storing the key value kind of data. So in this example, I have demonstrate, let's say if we talk about the India, here we have the concept city, state, country, and pin. And let's assume in US we have city, state, country, and zip. So here the pin is not available. Instead of pin, we are using the zip. And let's talk about, there is another type of address we are storing, which is village, district, country, and postal code. So here again, like certain columns are missing and some new columns are being added. So if we had to support the similar structure in case of relational databases, we might be ending up adding some 4 or 5 column extra with the table, and the rows where we don't have the data for those columns. Let's say in the first row, we might not be having the column for village, district, and postal code. Those column will gonna store the null or the empty area. And let's assume like we are having another table, let's say order. So here in the order also we are having the order ID. There would be some ID, user ID also 111. Product is computer, and let's assume like there are certain like state tax is there with the computer, but with the other product there is no state tax. And let's assume here in the mobile we are having the import tax, but with the other item there is no import tax. So in such kind of data, the NoSQL goes very well. Now, if we can see here, the user ID is defined 111, and here also we are having the user ID 111, but there is no defined relationship in the NoSQL. So there is no structure like this is a primary and this is a foreign key. This is all we'll have to handle programmatically. So that support is not there in the NoSQL, and that is where the power of flexibility and scalability come in the NoSQL. Now, since we saw both the relational and NoSQL databases, let's talk about the NoSQL product category. So there are like basically broadly four types of stores available under the NoSQL category. One is the key value store. Second one is the document store. Third one is the white column store, and fourth one is the graph databases. Now we'll see each in the detail. So we'll start with the key value stores. So the key value stores, we'll see there's a database. Under that we define the table. So in this example, we have a database and table user and table order. And if we'll see it closely, the data is stored in the form of key and the value. So ID is a key, 11 is a value, first name is a key, ABC is a value, last name is a key, XYZ is the value. So on and so forth, we can store the data. Then there is another record in the user table. Let's say ID is here, it's a typo. It should be 112 or some other value. And first name, last name, and different field can come. And if you notice, the records in the first data and the record in the second user data might be different. So here we haven't defined the last name, but here we have the last name, but here we haven't defined the last name. Now we'll see the order table. Here we can see the ID, user ID is also defined here. There are product information. These row and the columns, the rows can be different because this is stored the data in the form of key value. So it can vary from the row to row. Now here also, so we can see the user ID is given 111, and here also it is 111, but there's no defined relationship in the key value stores. That everything will have to handle programmatically. Now let's talk about the popular use cases. So where the key value store kind of database fit well. where it is being used popularly. So caching, session management, lead board where we are having numbering. Let's say some event is going on and we want to show for second, third, fourth. So in that scenario, that will go well. The example of the no key value stores database are Redis, DynamoDB, and Oracle SQL. Now let's talk about the second category of the NoSQL database, that is the document store. So the document store basically store the data in the form of binary JSON or BJSON, we call it to BSON. So here, if we'll notice, here we don't have any table. Here we call it databases. So here, if we'll see, the user is one database, order is one database, and the data is stored in the form of, you can assume this is like the data is storing something like the JSON here, and we define the property and the value for it. So ID, and there is some value for that first name, and there is some value for the last name, some value for that. So like that, the values can be stored in this. Now here, the one point here with the document databases are, like here in the orders, if we can see, we can provide the order ID, and that can be the reference to the other database. So here in our case, 200 is given as an like a reference to the record in the order database. Similarly, there is another record in the user table. Here, there are two orders against this users, and the reference can be defined. So this kind of database is very well with the blog, website, and the content management system, where and the application where we'll have to show the product catalogs, the big data, and the analytics. And the example of this data is MongoDB, Apache, CouchDB, Azure, Cosmos DB. Now let's talk about the third category of NoSQL database, which is the white column stores. So here we have to define the schema in advance. So when I say the schema, that means we'll have to define the super column. So the column concept is like the column. This is here we have to define the column family. So let's assume the first name and the last name in this table is coming always together, and it has to store at the same time. So we can define a column family for the name. Under that, we can define the first name and the last name. Similarly, for the address, city, state, and country, we can define. So this type of database would be very useful where we know our queries in advance. There may be like some limited set of query we'll have to run against our data. So, and if we know those query in like advance, like what all of the query will have to run, so we can define the super column here, and we can define the column family completely, and that data can store in the table. Now the one point is the data also can vary from one row to another row. So here if we'll see, we have three column, super column, name, address, and order. So the first row is having the name stored and the address and the order, but the second row is only having the name. So address and order might not be available for the ID 111. Now here we are having the order table. Again, we can see the product and all those detail like defined with the super column in the column. And this type of database like is popularly used for the IoT, like Internet of Things, where we have to store the data in real time and we'll have to do some sort of analysis. Then in the inventory management system, this fits very well. The big data also, it could use this like the white column stores. And the example is the Cassandra and the HBase. And if we'll talk about the Cassandra, it has its own query language, which is the Cassandra query language, which is very much similar to the SQL. So we can write something like select like user from table, and where like we can provide different details. Now let's talk about our fourth and the last category of the NoSQL database, which is the graph database. This is a bit different from the other. So here, if we'll see, we have the database. Under that, we have the node and the ages. So the node, if we'll see, the node is like, let's say the person ABC. He's a friend of person XYZ. So the person ABC and XYZ would be a node, and the age is the friend of. So this is basically age will define the property under that particular person. Similarly, the person ABC can have the address. So address can come as an edge, and the city, state, and country can store in the key value format as an property to the other node. And this type of database are very popular with the social networking side, where we'll have to store the relationship, like the person who is having 10 different friends, or the person A like person B's post. In such type of scenario, the graph database is really comes out very well. And in the case of identity access management system like IAM, also this fits very well in the recommendation engine. Also, the graph database used well. And the example of graph database are Neo4j and Genesis Graph. Now, so far we have discussed about all the categories of the NoSQL databases and their the popular use cases and the example. So that is like all about this video. If you like the video, please do like and subscribe to the channel. Thank you.